Good morning. This is very important lemma. If f is bounded variation on closed interval AB, then we have to show these two. That is, fb minus fa is equal to the difference of the positive and negative variation of f over closed interval AB, and the total variation of f over closed interval AB is equal to the sum of the positive and negative variations of f. So before proving this, let's recall few results. I have already discussed these results in the previous content. First one is capital P less than equal to capital T. That is, the positive variation of f is less than equal to total variation of f. And capital N is less than equal to capital T. Capital N is the negative variation of f, which is less than equal to the total variation. And the total variation is less than equal to sum of the negative and positive variation of f. And also, if t is finite, we are saying that f is of bounded variation. And then second one, this is very important, used many times. The difference of positive and negative variation is equal to fb minus fa. Then third one is, please remember, when we take the supremum of small p, we get the capital P, right? Likewise, the capital N and capital T, where if small p is equal to this right hand side and small n is equal to this right hand side, then small t is sum of n and p. That is, t is equal to, we take the summation on the modulus of fxi minus 1. Here we are having the mod and here we don't have the mod, right? This all I have discussed in the previous content. Please check from that, right? This all I have already discussed in the previous content. Please check from that. Okay, first I'm going to show that fb minus fa is equal to the positive variation of f over ab minus the negative variation of f over closed interval ab. This means that n is the negative variation of f over closed interval AB. So for this, let's take small a to be equal to x0 less than x1 less than x2 less than x3 up to so on xk, which is equal to small b, be any subdivision of closed interval AB. It is a subdivision of closed interval AB. And let's define small p to be the summation on f of xi minus f of xi minus 1, that is the positive variation of f, and small n to be the summation on the same f of xi minus f of xi minus 1, that is the negative variation. Then small t is the sum of p and n. That will be equal to the summation on, we take the summation on the mod, the absolute value of f of xi minus f of xi minus 1. Very fine. Okay. To get capital P, we take the supremum of small p. So that is your capital P, the positive variation of f over closed interval AB. To get the capital N, we take the supremum of n. So that is capital N. Please don't confuse, this is one and the same thing. This AB represents that f is over closed interval AB. And then capital T can be taken as supremum of small t. Then from the first result that we have recalled, the capital P is less than equal to capital T, and obviously capital N is also less than equal to capital T. So writing this, P is less than equal to T and n is less than equal to t, and also the difference of small p and n is equal to f of b minus f of a. Taking this minus n to the other side, we get p to be equal to f of b minus f of a plus n. And we know that if I take the supremum of small n, I will be getting the capital N. So can I write that this small n is less than equal to capital N? Yes. So from here, can I write further that this small p is less than equal to fb minus fa plus capital N? Yes. Can I write like this? Very fine. Now in the next step, I'm going to take the supremum on this over all possible subdivisions. We get this small p will be changed into the capital P, which is less than equal to fb minus fa plus capital N. And since we know that capital N is less than equal to capital T and this T is finite, I can take this N to the other side. So that is P minus N less than equal to FB minus FA. It is important to write this. And now marking this as 1 because I need to show that this P minus N is equal to F of B minus F of A, the first result. And now required to show that P minus N is greater than equal to FB minus FA. So when I show this, so from this one and this second result, I will be getting this equality. Since we know that the difference of P and N is equal to FB minus FA. We can also write this further as N minus P to be equal to F of A minus F of B. So this further implies N is equal to P plus F of A minus F of B, right? In the previous step, we have taken P to be on the left hand side. And in this step, this time, we are taking N to be on the left hand side. And because I know that this small p is less than equal to the capital P, so I can write this further as small n to be less than equal to capital P plus F of A minus F of B, isn't it? So let me write this again. And now taking the supremum over all possible subdivision of closed interval AB. So when taking the supremum, we get this small n is changed into capital N and is less than equal to this P will be changed into capital P plus F of A minus F of B. And from here we get that since this capital P is always less than equal to capital T, which is finite, so I can take this capital P to the other side. So writing capital N minus capital P less than equal to F of A minus F of B. Or if I take the minus common, I get P minus N inside the bracket less than equal to, also taking negative common from this, we get F of B minus F of A in the bracket. And if you cancel these negative sign, you get P minus N to be greater than equal to F of B minus F of A. Please mark this as 2. And from 1 and 2 we get P minus N to be equal to F of B minus F of A. Here we have proved the first result. And now we are going to prove the second result, that is, the total variation of f over closed interval AB is equal to the sum of positive variation and negative variation of f over closed interval AB. We know that, again, capital T is greater than equal to small t. This we know that, right? And we also know that the small t is equal to the sum of p and small n. Now because I know that the difference of P and N is equal to F of B minus F of A, or we can also write this as N minus P to be equal to F of A minus F of B, right? I need the value of N. So from here I get N to be equal to P plus F of A minus F of B, right? I'm going to use this value in place of this N. So what I get, the capital T to be greater than equal to small p plus, using this value we get P plus F of A minus F of B. So this becomes twice P. So this capital T is greater than equal to twice of P plus F of A minus F of B. We can also write this further as, if I take negative common, I get F of B minus F of A. We have just proved that capital P minus capital N is equal to F of B minus F of A. And I'm going to use this value of FB minus FA over here. So let me mark this result as star. So using star we get twice of P minus f of b minus fa is capital P minus capital N, right? Reason using star, or the first result which has been proved. So further, this is equal to twice of p, opening the bracket, this is minus p plus n, or twice of p plus n minus p. And now if I take the supremum over this, that is taking the supremum over all the subdivisions, the possible subdivisions of closed interval AB, we get what is changed now. What will change now? The small p will be changed into the capital P, right? So we get t to be greater than equal to twice of capital P plus n minus p. So 2p minus p becomes capital P. So this further equals to 2p minus p is p plus n. So we have got t to be greater than equal to p plus n. We have proved this. Let me mark this as 1. Required to prove that t is less than equal to p plus n. If I prove this, so from 1 and this result, we can say that this t is equal to capital P plus capital N, right? So required to show that t is less than equal to p plus n. This we need to show now, right? So again, since we know that small t is equal to the sum of p plus n, right? So this is further greater than equal to capital P plus capital N. Why? Because what is p? It is the supremum of small p. And what is n? It is the supremum of small n. So I can write this to be greater than equal to capital P plus n, right? So therefore we get small t to be less than equal to p plus capital N. And if I take the supremum over all possible subdivisions, this small t will be changed into the capital T when taking the supremum. So let's take the supremum. Taking the supremum over all the possible subdivisions of closed interval AB, we get what will change? The small t will be changed into the capital T and is less than equal to capital P plus capital N. Please mark this as 2. So from 1 and 2 what we get? What is 1? That t is greater than equal to p plus n. And now we have shown that t is also less than equal to p plus n. So from 1 and 2 we get t is equal to p plus n, right? So both the parts has been proved and it is very easy to prove them. Just you need to take care of the steps. Alright, thank you and stay blessed.